Get everything in place. And we have most of our participants connected. Let's get started on today's session. Thank you all for waiting patiently. Good afternoon to one and all. The brilliant minds join us from different corners of the digital universe. Just as electrons move in search of stability, today we gather here in search of knowledge. Thanks to the power of technology, our classroom has no walls, no borders, and only boundless learning. Education is not the learning of facts, but the training of the mind to think, a saying by Albert Einstein. In line with this thought, this FPP provides the right platform to train our minds, exchange ideas, and explore new perspectives. With that spirit, we begin day two of the 5-day International Online Faculty Development Program on recent trends in chemical sciences and engineering, organized by Department of Chemistry, New Prince Bhavani College of Engineering and Technology. To take the session forward, now I invite Professor Aidama to deliver welcome address.
Good afternoon to one and all present here. On behalf of our institution, it gives me immense pleasure to extend a warm welcome to our management, our beloved principal, the heads of various departments, all my dear faculty colleagues and participants gathered here for this online faculty development program. We are also deeply honored to have with us today our distinguished guest speaker, Dr. Vinuta Vishnukaman, Assistant Professor, Department of Chemistry, Dayananda Sagar College of Engineering, Bangalore, Karnataka. Dr. Vinuta is a highly qualified academician who has completed her postdoctoral fellowship and has made significant contributions to the field of research. She has published more than 40 research articles in reputed journals, and her research interests span across a wide range of areas, reflecting her academic versatility. In recognition of her excellence, she has received several awards and fellowships. Beyond her personal achievements, she has also guided many students in their projects and research work, inspiring them to reach new heights in their academic journey. With such an outstanding profile, we are indeed fortunate to have her with us today. On behalf of our entire gathering, I extend a very cordial welcome to Dr. Vinuta, and I am confident that her session will be enriching, enlightening, and inspiring for all of us. Welcome you all. Thank you.
Thank you so much, ma'am. And now, without further delay, let us not just connect to our devices, but also with open minds and curious hearts. With that, I hand over the session to our distinguished speaker.
Thank you, ma'am. Thank you for your warm welcome. Good afternoon, everyone. Now I'm going to talk about the biogenic synthesis of silver nanoparticles from neem, dual properties as antioxidant potential and dye degradation. So before going to start my talk, I'd like to tell something about our FDP topic, that is FDP theme, that is recent trends in chemical sciences and engineering. So why we have to focus more on chemical sciences? So that is because of the chemical sciences creates awareness of the latest research and technology. It shows the relevance of chemistry in solving global challenges like energy, health, environment, and etc. Highlighting the future opportunities in advanced materials, nanotechnology, sustainable chemistry, etc. So why we have to focus, like why we have to choosing alternative methods over the conventional synthesis? Because there will be like lots of challenges are there with the conventional synthesis. There are various methods various physical and chemical methods are there, which includes chemical reduction, electrochemical, photochemical, thermal decompositions, etc. Challenges with the conventional synthesis includes low atom economy, use of toxic reagents or solvents, high energy consumptions, lengthen the procedure, poor selectivity, environmental hazards, etc. Not only this, during the synthesis process, we are using various toxic chemicals as a reducing agent or fuel, or we are using some solvents. They are like toxic to the body or even for the environment. Not only that, to perform that reactions, we required high energy. So due to this, there will be like more cost we have to required. And reagents, we are using some palladium, platinum agents. These are all costly, and sometimes we are using chromium and all. These are all toxic to the environment. So not only this, while scaling up for the industrial applications, or we need to prepare it in the larger scale, there will be like limited scalability will be there. That means we cannot do it in the larger scales. These drawbacks make them less sustainable, and even for the problematic for the biomedical and the environmental uses. Due to this, we have to choose some alternative methods. Uh, Among them, major one is the green synthesis. Green synthesis, a sustainable alternative. Green synthesis, why we have to focus more on green or green technology? Due to its eco-friendly and cost-effective approach that avoids toxic chemicals, uses natural reducing agents, consumes less energy, and produces biocompatible and sustainable materials suitable for the biomedical and environmental applications. Mainly, we have used either plant extract, or that is from plant source or from the animal, or some bacteria and fungi also we are using as a natural reducing agent, because these will contain natural products like polyphenols, flavonoids, terpenoids, and etc. So these plant extracts, due to the presence of natural products, that is like alkaloids or terpenoids and all, they are having natural as a main backbone, or like flavonoids or polyphenols as a oxygen as a main core element, which act as a natural reducing agent and a stabilizing agent. Advantages over conventional synthesis and green synthesis is that, like green synthesis are eco-friendly, because we are not at all using any toxic chemicals or like any reagents. We are using a plant or animal, that is like a biomaterial as a core fuel. So there won't be any toxic byproducts. And sometimes we are using bio waste, so there will be chances are there for the like cost effective, because plant sources are abundant in nature. Next is biocompatible. These are like suitable for the biomedical uses, because we are using main bio sources. So there will be like biocompatibility more, and there will be like less toxicities there. Next is the simple scalable protocols. So next we are focusing more on the nanotechnology and the nanotechnology. Nanotechnology and silver nanoparticles. Nanotechnology explores materials in the range of 1 to 100 nanometer scale, where unique optical, electronic, biological properties arises. Silver nanoparticles are among the most studied nanoparticles due to their antimicrobial, antioxidant, anti-cancer, catalytic activities. They have broad applications in medicine, textiles, sensors, food packaging, environmental remediation, etc. Not only this, silver is like known to us from the ancient days. We have to use silver material, silver for the various biomedical applications also. So silver nanoparticles, due to their high catalytic activity because it provides larger surface to volume ratios, and its properties will results in the exploring more in the silver. So next we have choose the neem leaves. Neem leaves as a green source for our preparation of the silver nanoparticle. Neem leaves are rich sources of bioactive compounds such as flavonoids, terpenoids, tannins, and alkaloids, which act as a natural reducing and stabilizing agent in green synthesis. They provide eco-friendly, cost-effective, and sustainable alternative to chemical methods for nanoparticle productions. Additionally, neem's antimicrobial, antioxidant, and medicinal properties enhances the biocompatibility and functionality of the synthesized materials, making it valuable for biomedical, pharmaceutical, and environmental applications. So neem medicinal plants widely available in India, and its biological name is Azatea indica. It contains various bioactive compounds. These bioactive compounds act as a reducing agent as well as the capping agent. So it will converts Ag plus to Ag0, and it acts as a capping agent, which prevents the aggregation, stabilizes the nanoparticle. Not only this, this provides eco-friendly, sustainable, and abundance resource for the nanoparticle synthesis. Next is the preparation of the neem powder. So here we have used neem plant for the starting core or the fuel for the synthesis of silver nanoparticle. Neem leaves we have harvested from the plant, and we have washed with the double distilled water and dried under sunlight for 1 week. So here we have to dry it in the absence of sunlight to save the bioactive compounds. Next, we need to grind with the help of mortar. Here we should not use any mechanical or any other mixer or any other agents for the grinding purpose. So then these powders were stored in the airtight container for the synthesis of the nanoparticles. Next is the green synthesis of silver nanoparticle. Synthesis of silver nanoparticle was done by the solution combustion method. So here we have used neem leaves as a dried neem leaves as a fuel. So mixture of silver nitrate and neem powder in the ratio of 2:1 were used. This mixture was were dissolved in 15 ml of double distilled water. This we need to transfer into silica crucible, and we have to heat for about 800 degrees centigrade for 60 minutes in a muffle furnace. Next, the synthesized silver nanoparticles were characterized with the help of various analytical techniques, that is XRD, FTIR, FSM, and UV visible spec. So XRD peaks corresponds to 210, 122, 111, 200, 231, etc. planes. Confirms the silver nanoparticle planes of silver indicated by the face-centered cubic structure of the nanoparticle. XRD measurement shows that extract results in the formation of the solid nanoparticles, silver nanoparticles. The particle size of the silver nanoparticle is evaluated by using Debye-Scarsdale equations. Next is the FTIR technique. Metal nanoparticles undergo stabilization, capping, reduction due to the plant extract. Peak at 1342 corresponds to the OH bending. Peak at 3248 centimeter inverse corresponds to OH stretching. which this is due to the presence of the aliphatic carboxylic acids. So these peaks were mostly attributed to the abundance of flavonoids, terpenoids present in the plant extracts. So this is the FSM image of the synthesized silver nanoparticle. FSM depicts with the small spherical-like form, exhibits the high uniformity in size and uh, constant distribution over the area with the surrounding vacuum spaces. Next is the UV visible spectra. So synthesized silver nanoparticles were synthesized silver nanoparticles UV spec were recorded and top plot were drawn. So UV visible and top plot spectrum shows that the generation of silver oxide Ag nanoparticles, silver nanoparticles confirmed by the surface plasma resonance band centered at around 450 nanometer. So further, synthesized nanoparticles antioxidant properties were determined by using various assays. So antioxidant properties are like important. So synthesized nanoparticle antioxidant properties with the DPPH, ABTS, FIRAP, and FICAP assays were evaluated. So with all assays, we can here DPPH and ABTS assays are there. So here different concentration, that is 100 to 500 microgram per ml concentration of the synthesized nanoparticles were used. These color for the ascorbic acid and this green color for synthesized silver nanoparticle. So here ascorbic acid is used as a standard drug because ascorbic acid we are using as a standard, as a regular medications. So this is the antioxidant result of the DPPH assay. From this results, we can tell that synthesized nanoparticles shows good antioxidant properties. Even though it's showing little lesser antioxidant property than the standard ascorbic acid. So here this is the ABTS assay. So here also we have used same concentration, that is 100 to 500 microgram per ml. So for all the assays we have used the same concentration just to check how that varies with the different assays. So in this assay also we have used ascorbic acid as a standard drug. So as similar to that of the DPPH assay, ABTS assay is also silver nanoparticle showing little lesser activity compared to the standard. So next is the FRAP and FICA. So here FRAP and FICA. For the FRAP, we have used ascorbic acid as a standard drug, and this follows similar trends as DPPH and ABTS assay. So FICA, that is ferrous ion chelating activity. So as it is chelating reactions, here we are using a hexadentate ligand, that is ethylene diamine tetraestic acid as a standard drug. So for all the antioxidant assay, the silver nanoparticle shows a little lesser antioxidant properties compared to the standard drug choose, but efficiency is like good, because that is like it is showing nearly 92 to 95% antioxidant properties. So here FRAP is the ferrous reducing antioxidant power. So here also same trend as in the DPPH assay. So these two assays assesses the capacity of the compounds to inhibit the production of potentially dangerous hydroxyl ions radicals. So hydroxyl ions are like dangerous So it has to eliminate from our body. So whether our synthesis nanoparticles is like easily eliminating the hydroxyl ions or not, just to know that we have performed these two assays. So here we got good results. So next is the comparative study of the previously reported literature of the catalytic degradation. So there are various dyes were used for the degradation process. Methylene blue, methylene blue, methyl orange, malachite green, orange G, and rhodamine blue, methyl violet already used. So they have used different time intervals for the degradation, and efficiency is also like good. That is, they already achieved more than 80%. So because of that, we have selected some dyes, and we are thought of doing catalytic degradation, because already silver nanoparticles showing good results in the catalytic degradation. So synthesized silver nanoparticles photo degradation of malachite green, uh, orange green, rhodamine B, methyl violet dyes under UV light source were evaluated. These experiments conducted at room temperature using a UV lamp. Dye concentration was monitored over time by measuring the maximum wavelength at constant 10 minutes intervals, revealing the significant decrease as the reactions progressed. Here we have used same dye concentration and same volume for all the dyes. So this is the photocatalytic activity of the silver nanoparticle with the various dyes. This is the degradation of malachite green, orange green, rhodamine B, and methyl violet dyes using silver nanoparticles under UV light. So here we have maintained same concentration and same volume to compare the activity against the various dyes. So almost for all the dyes, activity was similar. So percentage of dye degradation was calculated by using this formula, that is Ca minus Cb divided by Ca into 100. So from that we can calculate the percentage of degradation. So next is the kinetics of the dye degradation. Kinetic study plot illustrate that the progressive degradation over the time confirms that degradation process follows the first order kinetics. As the time interval goes on, so there will be decreasing trend is observed. So these two for the A and B for the kinetics for the dyes, and then further this is the um, plot of the half-life. So half-life data confirms that high efficiency of silver nanoparticles rapidly decreases 50% of the dyes within shorter time, relatively shorter duration, showcasing their excellent photocatalytic performance. Here, T half of mg green is like 20 minutes, and OG dye is also nearly like 20, and rhodamine B is like 26.62, and MV dye is 40 minutes. So here we have used a rate constant with the help of Kt is equal to minus ln C by C naught. Here C and C naught are the concentration. Rate constant K validated the strong catalytic activity of the silver nanoparticles. The excellent performance of the photocatalytic degradation highlights the effectiveness of silver nanoparticles in dye decoloration. So the results in the photo degradation experiments evaluating the catalytic reusability. So if we have using catalyst, we have performed repeatedly, so it will be like giving same efficiency as that of the fresh catalyst. That means we can use it for the repeated cycles. So that will indicates that same catalyst we can use for the for a repeated cycle. So as shown in figures, the results of the photodegradation experiments evaluating the catalyst reusability. After each cycle of the catalyst, it was successfully recovered and it was like filtered and filtered with the help of a Whatman filter paper, and we have used it for the next cycle. So therefore, we have used same catalyst for 5 times, 5 consecutive cycles without significant loss of efficiency. Hence, it shows the recyclability of the catalyst. That means we can use catalyst for a number of cycles. So next, this graph, this plot explains the pH of the absorption media plays a crucial role in influencing the absorption rate. So here we have used different pH range, that is 3 to 11, that is acidic to alkaline pH we have used, because for the water treatment or dye degradation, we can use any range of samples, just to check which pH or what is the range of the pH. We have used we have used different pH. So here, as the percentage of the dye removal remains stable at lower pH values, but decreases as the pH increases from 9 to 11. That means we can use catalyst for like up to pH of 9. This will be good at acidic pH, indicating the reduced dye removal efficiency in more alkaline environment. So this is the overall scavenging studies of the uh, synthesized silver nanoparticle. So conclusion. So here we have used silver nanoparticles with the green technique, that is fabricated using the neem leaf extract with the help of a solution combustion method, offering eco-friendly and cost-effective approach. So these were characterized, their structural, morphological, and optical analysis confirmed the highly crystalline, uniformly distributed silver nanoparticles with the band gap of 2.31 eV. These were with the various antioxidant assays. This shows 90% antioxidant activity in multiple assays, highlighting the promise for the pharmaceutical and healthcare applications. So these were showing 94% of the photocatalytic degradations of azo dyes, because almost we have used all the azo dyes with the 10 minutes, providing the suitability for the water treatment, mainly acidic water. So with the help of kinetic studies, recyclability, and scavenger analysis, validated their stability and long-term efficiency and its reusability. So these silver nanoparticles showing multifunctional nanomaterials for sustainable biomedical and environmental applications, with potential for the scalable productions and real world use. So at the end, I would like to acknowledge management and organizing committee to invite me as a invited speaker. Thank you, one and all.
Thank you, ma'am. Thank you so much, ma'am.
Okay, sir. Thank you.
Just a minute, just a minute. Thank you so much, ma'am.
Okay, sir. Shall I leave the meeting, sir?
No, wait, ma'am.
Okay. Sir, is there any questions or any queries?
Dear participants, any questions or clarifications you can ask to Vinita, ma'am. Dear participants, any questions or clarification you can ask to Vinita, ma'am.
Some questions are there in chat box, ma'am.
Tell me, ma'am.
I'll tell one by one. Is that silver nitrate can be used for green method? Someone, Bharati Alini, is asking that question.
Yes, ma'am. We can use silver nitrate or silver chloride. We can use, but in this experiment, I have used the silver nitrate.
In one more question, ma'am, what is the role of neem here?
As a fuel, ma'am. Fuel. We need one fuel, so we have used neem as a fuel. So it will provide a matrix for the silver to cap on that.
Okay, ma'am. Another question: which solvent you are using for the
Water.
part?
Water. I have mentioned there, ma'am. Distilled water.
Somebody is asking some applications of this work, ma'am.
Hello, excuse me,
Lakshman Kumar sir asking some applications of this work.
ma'am.
Participants,
Hello.
kindly unmute one by one.
Hello, ma'am. Ma'am, I am Muthumanikam from Malla Thirumal College. Can you audible, ma'am?
Vinita, ma'am, is it audible for you?
Yes, ma'am.
Okay,
Yes,
ma'am. Okay.
no, thanks for your wonderful presentation, ma'am. My question is, did you noted the yield of the silver nanoparticle when you synthesis in a biogenic way, ma'am?
Sir, yield it's like difficult to calculate. In organic or inorganic material, we can calculate yield easily. But here we are using fresh leaves to we will be drying. So there will be chances are there for less. But after when we are calculating dry neem powder and then end product, we are getting nearly 90 to 92% yield, sir.
In a gram calculation, if you take 10 gram of silver, how much amount of silver nanoparticle we can get, ma'am?
Because sir, I have mainly concentrated on neem powder. So for that, 2:1 ratio I have took. So for 10 gram, nearly around 9 something I got the yield, sir.
Yes, ma'am. Yes, ma'am. Thank you.
One more question some are asked, right? Like for the application part.
Yes, ma'am. Someone is asking the applications part of your presentation or
So
research.
we can use it for the electrocatalytic applications also. We are working on it, ma'am. And not only that one, even we can use it in the film preparations and all. Film preparations, once we have prepared film, we can use it for the packaging and all, food packaging and all. So that process is we had a plan. So that film preparation and all taking place. So based on that film, we will think about which type of packaging or on which type applications we can think further, like that we are focusing on.
Some questions are there in chat box, ma'am. Did you notice the yield of silver nanoparticles, ma'am? Like that someone is asking.
That I already told, ma'am. 90 to 92% yield I have achieved, ma'am.
Did your study cover the lifespan of neem nanoparticles?
Not yet calculated, ma'am, because recently we have prepared. We will work on that also, so that we can keep it for longer time or not. We will check. As of now, it is stable only. We have checked for 1 month, up to 1 month. We have checked its efficiency, dye removal. So it's showing results as compared to freshly prepared catalyst. So it's showing up to 1 month stability is there. Further, we have to check, ma'am.
Okay, one more question, ma'am. Have you studied NMR for flavonoid? Somebody is asking.
No, ma'am. For pure compound only we can record NMR and all. So here we cannot use NMR because it's there will be so many natural products are there. So it's difficult to analyze the NMR because there will be terpenoids also there. Flavonoids also there, terpenoids also there. So we cannot use NMR technique.
Then have you confirmed the effect? Yes, go ahead, sir.
Good afternoon. Nice presentation.
Thank you.
What is the synergistic effect of neem, ma'am? You are prepared the silver nanoparticles. If it is prepared without neem, what is the effect? By the neem, what is the effect? Can you compare it, ma'am?
Yeah, yes, ma'am. Good question, ma'am. Silver nanoparticles, we can prepare with the help of some other methods also. But here we have using as a neem as a capping agent. We will be having facing less toxicity. Toxicity won't be there. So because there will be, if we are using directly, there are chances are there for the toxicity and all. Here, when compared to we are using as a any plant extract as a fuel, so there will be toxicity problem won't be there because it's a neem is a biomaterial. Even we can use some other we can combine with some other fuels also. We can use any urea or citric acid as a fuel, but there we need to check for the toxicity also. But when compared to neem or any plant source, toxicity is less. So we can use it for the biomedical applications easily.
Okay, ma'am.
Ma'am, one more question. Have you confirmed the effect of neem comparatively than other work?
Means I didn't get the question. Neem with other plant, other
the effectiveness
plants.
of the neem, yes, ma'am. Did you compare with some other work like?
For silver nanoparticles, I didn't check, but for other previous work, I have used the same plant for various metals I have prepared. There I have seen like it will varies, depends metal to metals, its applications or its properties varies. Here I want silver, so I have prepared because of its applications. In olden days, we have using both neem and silver, both for the biomedical applications. Like for kids and all, they used to give in the silver vessels and all. That will be like easy for biomedical applications. To check the role of silver with the neem, I have combined these two, and some other biomedical applications are like uh, under progress, ma'am.
And what is the lifespan or stability of the neem nanoparticles?
Ma'am, just we have prepared recently, so like we are planning to check its lifespan for every month intervals and all. Now already we had checked the catalytic efficiency of nanoparticles for 1 month. So we'll check, ma'am, because till now we didn't finish it. So once we'll be like finish, we'll tell. Just for like up to 1 month, stability is there.
Okay, ma'am. One more question, ma'am. How it will enhance the activity that neem nanoparticles? How would enhance the activity that Kyle will is asking that question?
Like, ma'am, we are using fuel. So, like normally, how the fuels will help means they will be like providing neem plant. There will be so many constituents are there, biologically active constituents are there, that will help to enhance the activity with the help of silver. Here, the constituent present in the neem will combines with the silver, so that will act as a like a catalyst to increase its efficiency. It may be for biomedical applications or like catalytic, like dye degradation. Not only this one, even we can use it for the electrocatalytic applications also. The study is like under progress. We are performing that part also, like water splitting and all.
One more question, ma'am. Which type of characterization technique did you use to study the stability, ma'am?
Stability, as of now, I have used the like I used to record its XRD and SEM, and then I used to check for its dye degradation, if it is showing dye degradation or not. Like that, I am comparing just for for half an hour. I mean that means like half an hour only. I am checking the its stability, whether it is showing catalytic property or not. Like that, I am checking along with its XRD and SEM.
Okay, ma'am. Since no more queries are coming in the chat box and also no questions from the participants, we shall conclude the question answer session. Thank you to the participants for their thoughtful questions, and a very special thanks to our speaker for addressing them so clearly and patiently. Thank you so much, ma'am.
Thank you.
Your talk beautifully traced the journey from traditional approaches to sustainable methods. Actually, it's showing us how science can evolve responsible with environmental concern in our mind. So it's very clarity and depth which explained the concept, gave us a very fresh insights into the importance of particularly green chemistry. Thank you so much, ma'am.
Thank you.
Every memorable session deserves words of gratitude. Gratitude is the bridge that connects efforts with appreciation, and today's session is a reflection of both. To express them gracefully, I invite Professor Dr. Sabri sir to deliver the vote of thanks.
Thank you, ma'am. Good afternoon to everyone. On behalf of the organizing committee, I am sincerely thanks our resource person, Dr. Vinitha Vishnukumar, for sharing their valuable insights and enrich our knowledge. And my heartfelt thanks to our management and principal for their constant support. And we sincerely thanks to the participants from various institutes and industries for their active involvement and cooperation. And once again, thank you all. Thank you so much.
Thank you so much, sir. Participants are requested to kindly turn on their video for a moment. Please turn on your video. We'll just take a photograph of today's session. Thank you so much, participants. Kindly turn your video on. Thank you so much all. And with this, we wrap our day 2 of our International Online Faculty Development Program. Today's session has left us with fresh insights and new perspectives to reflect upon. We thank our speaker and all the participants for your active involvement, and we warmly invite you to join us again tomorrow for day 3 at the same time through the same platform. Wishing you all a pleasant evening ahead. Thank you so much.